The metric system is a decimal system of units, and it is built around the standard units. So it does use prefixes, and we represent those as powers of 10, just to express the quantities that are larger or smaller than the standard units. So, for example, a kilometer is more than a meter. So, to represent that as a metric system, we say that the kilometer is 1,000 meters, so it's 10 to the 3 meters in there. This is the conversion for all the units over here to 2 meter. And you're not responsible to memorize any of those. I will give you a table and I will give you the conversion for all of these units. So for example, length is measured in meters. This is the basic unit of the metric system. It can be measured in centimeter and decimeter, but the unit that normally they measure length with is meters. Volume is measured in liters. It can be measured in milliliters, but in most of the cases it's measured in liters. Mass in grams. It can be measured in kilograms, but again, it is the metric system unit is the grams. Time is in seconds. Temperature is in Celsius. Energy in calories. And the amount of substance is measured in moles. So to solve any conversion problem, we're going to use this formula that you see. We're going to take the unit that we want to convert it, and we're going to multiply it by a conversion factor to change it into another unit. Whenever we are doing this conversion equation or this conversion formula, we always want to make sure that unit 1, or always the conversion factor that we're using, should cancel unit 1 and should introduce unit 2 so that our answer is in unit 2. Okay? So the conversion factor must always accomplish two things. The first thing is that it must cancel. In this example, I'm changing the meters to millimeters, right? So the conversion factor must cancel the meters, and at the same time, it must introduce the millimeters so that my answer is in millimeters. So let's have an example there. How many millimeters are there in 2.5 meters? This is given. It's given that 1 meter is 1,000 millimeter. Whenever you're working with any problem like this, you always choose what is the given. So the given is 2.5 meters, right? This is your given. So you have to start with it, okay? So you have to start always with the given. So this one is going to be 2.5 meters a day. I want to multiply it with the conversion factor. So the conversion factor must cancel the meter. If I want the conversion factor to cancel the meter, so the meter has to be in the numerator, in the denominator, not the numerator, in the denominator in there. So I know that 1 meter is 1,000 millimeters, right? So the 1 meter is going to be there, the 1,000 millimeters is going to be up, and this is going to be your conversion factor. So the conversion factor cancel the meters. So that is going to be, I'm just going to take those two out. So you're going to cancel the meter, cancel the meter. So to cancel the meter, you need to divide by the meter to cancel that. And it should introduce the new unit, which is the millimeter. So your answer in this case is going to be 2500 millimeter. We need to change this into a scientific notation. So it's going to be 2.5 times 10 to the 3 millimeters in there. The 2.5 meters. This is your given, right? So always your total number of significant figures needs to follow your given because the conversion factor is always constant. So you cannot say, okay, the conversion factor is one significant figure, then my answer is one significant figure. No, the conversion factor, you don't look at its significant figures. You only look at the significant figure of your given and make sure that your answer follows that. Let's have another example. Convert 16.0 inches to centimeters in there. Given 1 inch is 2.54 centimeters. So now I want my conversion factor to cancel the inch and introduce the centimeter. That's what I want it to be. So see, you always start with your given. So your given is 16.0 inches. My conversion factor is I need to cancel the inches. So this is 1 inch. And that is equivalent to 2.54 centimeters. So my conversion factor here introduce the centimeter and it canceled the inches in there. So the inches are canceled out. And now my answer is going to be over here it's going to be 40.6 and it's going to be centimeter. Units are a must to add. So please make sure to put your unit because your number means nothing without your unit in there. What's remaining is the centimeter. We go ahead and we put the centimeter. See, my given was 3 significant figures, right? So my answer over here is going to be 3 significant figures. I don't care about my conversion factor, how many significant figures it is, because my conversion factor is fixed. It is a fixed conversion, so you don't follow its significant figure. Convert 3.7 times 10 to the 3 centimeter to micrometers. It's enough for me to give you the conversion factor in there, just for you to know what you need to do, right? Now, I gave you the meter to be 10 to the 6 micrometers. I didn't give you the centimeter. So now here what you need to do is change the centimeter into a meter, okay? So you're going to change the centimeter. I built myself a small equation in there. So just to tell me, it's like steps, just to tell me what I need to do. So I'm starting with a centimeter. I want to change it into a meter, and then I know from meter to micrometer how much is that, right? I know at the same time that 1 meter is equal to 100 centimeters, so that should be an easy change in the unit. Always start with the given. So the given is here, so I'm going to always start with that. There you go. So I'm going to always start with that, and it's going to be 3.7 times 10 to the 3 centimeter. What do I need to do first? I need to cancel the centimeter and introduce the meter. So to cancel the centimeter, I need the centimeter to be at the bottom, right? And I know that 100 centimeter is equal to 1 meter. So this way I cancel the centimeter, I introduce the meter. We move on. We can build this in one equation. Now I want to change the meters into a micrometer. So whatever you're finding, if you have noticed, the micrometer is whatever I want to find. Whatever you're finding is in the numerator. Whatever you're canceling is in the denominator. So here now I want to cancel the meter. So I know that 1 meter is equal 10 to the 6 micrometers in there, right? So this way I would cancel the meter and cancel the meter out, and I would be left with my micrometers at the end. Your unit is very important. Please do not forget that. And then you can simply plug your numbers in the calculator. For the 10 to the power, you have to use the exponent, the exponent option in the calculator. Please do not forget this. And the answer here is going to be 3.7 times 10 to the 7. This is already in scientific notation. I'm starting with 2 significant figures in there in my given. This is 2SF in my given. So my answer has to be 2 significant figures as well. Again, all of these over here, these are fixed conversion units. You don't look at their significant figures. Another example, how many kilometers are in 6.48 miles? You are given the miles, so we can easily build a conversion factor in there. It's always start with your given. Don't forget miles in there. So that is your given. And your given is how much sig figs. It's a 3 significant figures. So I know that my answer is going to be 3 significant figures. So now I want to cancel the miles and I want to introduce the kilometers in there. So whatever I want to introduce needs to be in the numerator. Whatever I want to cancel has to be in the denominator. This is going to be the miles. So you cancel the miles in there, and that is going to be 10.5 kilometers. And this is, again, 3 significant figures. More examples in there. I mean, it's the same concept. It is the same idea in there. Sometimes it is a 1 step. Sometimes it is a 2 step. So here, how many millimeters are there in 1 kilometer? So I know that a kilometer is 1,000 meter, and a meter is 1,000 millimeter. See, so it's going to be 2 steps in there. I'm going to start with a kilometer, go to a smaller unit, which is the meter, and even a smaller unit, which is the millimeter. And this is the conversion. So a 1 kilometer is 1,000 meters, and a 1 meter is 1,000 millimeters there. So we're going to start with always the given, always the given. So what is the given? The given is 1 kilometer. So that is the one that we are going to go ahead and start with. So this is going to be 1 kilometer. So now I want to change the kilometer to meter. So change to meters, I want the meter, right? So this is going to be in the numerator. The meter is going to be in the numerator. I want to cancel the kilometer, so it's going to be in the denominator. So these two units are canceled out. Then I want to change the meter into a millimeter now. So I want the millimeter to be in the numerator because this is the final unit that I need. And then I need to cancel the meter. So this is going to be the meter as well. So your answer over there is going to be 10 to the 6 millimeter. This is not in scientific notation. So that is going to be 1 times 10 to the 6. And that is going to be in millimeter. Those two are the same. So instead of writing it as 10 to the 6 millimeter, just write it as 1 times 10 to 1 point actually. So you have to write it as 1 point because you want to keep one sig fig, right? And you need the scientific notation, so you need a decimal in there. Your point has to be after the non-zero digit. So it's going to be 1 point. You cannot say 1.0 because if you say 1.0, that is a 2 sig fig, and you are actually starting with a one significant figure in there. So just pay attention to that. Same idea for the mass measurement. As long as you know the rules in there, and as long as I give you the conversion, you can go from one unit to the other. But just make sure you always cancel the unit that you start with, and you introduce a new unit that you need to find. Okay, this is the conversion factor over here. So 1 gram is equal to 10 decigrams. dg is decigrams. And 1 decigram is equal to 10 centigrams. And 1 centigram is equal to 10 milligrams. And 1 milligram is 1,000 micrograms. Okay, so this is going to be the conversion factor. So let's say, for example, if I want to go from a gram to a microgram, how much should I multiply with? See, it's going to be 10 times 10 times 10 times 10 to the 3, so this is going to be times 10 to the 6 to go from 1 gram into a microgram. So let's have an example for that one. So how many kilograms are there in 1 milligram? So given that 1 kilogram is 10 to the 3 milligrams there. So I know that you need to go from a kilogram to a gram and then to a actually you don't have to. So it says kilogram, gram, milligram. It's given that you are starting with a milligram. So here you go. Starting with a milligram, you want to go into a kilogram. So you are going over here. It's going to be times 10 to the 6. So you're going to divide by 10 to the 6. So I'm starting with 1 milligram. So that's going to be my given, you guys. Okay. So it's going to be 1 milligram multiplied by, I want to cancel the milligrams. And I know that 1 kilogram is 10 to the 6 milligrams. So the milligram has to be at the bottom, and I need to divide by 10 to the 6 in there. And that is 1 kilogram. So I introduced the 1 kilogram unit. So my answer is going to be 1 times 10 to the minus 6 kilograms. It's going to be 1 point times 10 to the minus 6 kilograms. How many milligrams are there in 1 microgram? Same thing. 1 milligram to a microgram times 10 to the minus 3. So I'm going to start with my given. My given is 1 microgram. So this is going to be 1 microgram. I want to cancel the microgram. So that is going to be 10 to the 3 micrograms in there. Because I know that 1 milligram is equal to 1,000 micrograms. So 1,000, I'm just going to write it. Either you write it as 10 to the 3 or you write it as 1,000. It's the same thing. This is 1 milligram in there. So I am canceling the micrograms. And it's going to be 1 times 10 to the 1 point times 10 to the minus 3 milligrams. If you write it as 1 or 1 point, it's both the same. Okay, so convert 45 decigrams to grams, given 1 gram is equal to 10 decigrams. Same idea in there. So we're going to start with our given, and our given has 2 sig figs now. So the answer has to follow that. So remember, we are doing here multiplication and division. We're not doing addition, subtraction. So this is going to be decigrams. My conversion is 1 gram. So I have to divide by the decigrams. This is 10 decigrams for 1 gram. So, okay, the grams do not cancel. So that is equal to 4.5 grams. You cannot leave it like this. So just make sure that you write it as a sig fig notation or a scientific notation. I know that I have two significant figures, right? So this is two significant figures, but I need the 10 to the power. Here, the power is going to be 0, okay? And my unit is going to be grams. Don't write it as 4.5 times 10 to the 0 without the unit because your answer is not going to be right. An atom of hydrogen weighs 1.674 times 10 to the minus 24 grams. How many ounces does the atom weigh? I am given the pounds and I'm given the ounces conversion, right? So start with your given, and my given over here is 1.674 times 10 to the minus 24 grams. So the idea here is that I want to change the grams into pounds. I want to change the grams into pounds, and then the pounds I want to change them into ounces. So it's a two-step in there. You can do them separate. So you can do the grams to pounds, and then go from pounds to ounces in two separate steps. But here I am combining them. I find it easy like that. And units, I find it easy to cancel the units. So here now I'm going to cancel the grams, and I want to introduce the pound. So I know that 1 pound is equal to 454 grams. This way I introduce the pound. Now I want to cancel the pound, so the 1 pound is equal to 16 ounces, and I want to introduce the ounces in there. Your answer has to be 4 significant figures, okay? The others are fixed units. So this is 4 sig figs, so here my answer has to be rounded up, okay? It's going to be 5.900. All of those are considered to be part of the significant figure numbers times 10 to the minus 26. And guys, your unit, please don't forget, which is the ounces in this case. Percent calculation. So with this one, this is the number of specific items in a group of 100 such items. So the formula for this percentage is part divided by the total. Any formula that is given in this course, you don't have to memorize, because at the end, you're going to have a sheet for every single chapter that includes all of these formulas, and you're going to bring those with you to the exam. This is one of them. You don't have to memorize that. So the question here is, student counts the money she has left until payday and finds that she has that much. Okay, so the total is that much. Before payday, she has to pay an outstanding bill of 15.67. That is part. So this is going to be part of the total that you need to pay. What is the percentage of her money left? So you do part divided by the total times 100, and your unit here is the percentage. So it's going to be a percentage. Okay. Another example, if 13 gram of fat is 19.99% of the daily value of fat in a 2000 calorie diet, how much fat would a person on a 2000 calorie diet eat? So here's what we have there. So what we need is the total. This is what we need. So we are given the percentage, which is actually the 19.99. We are given the part, which is 13 grams. So the 13 grams is the part. So we are given the percentage, we're given the part, we don't know what the total is. So we need to rearrange this equation in there so that it is read as the total is equal to. And in order to do this, here you go, this is an example. So if you have x equal a divided by b, and you want to find b, what do you need to do? What I normally do is I cross multiply. So xb is equal to a, right? And I come up with an equation like that. So let me erase those. So I come up with an equation like this. So xb is equal to a. And then what do I need? I need b, right? I need to find b. So I'm going to divide by x here, divide by x there. And now I have an equation of b is equal to a over x. We're going to do the same thing in there, okay? So we're going to do the same thing here. I need the total, right? So I'm just going to go ahead and rearrange this guy over here. So I'm going to make the percentage out of 1. So I'm going to make an equation of the percentage times the total is equal. Remember, I am multiplying those two together. Cross multiply. I'm multiplying those two together. Parts in the 100, I'm going to multiply them by 1, separated by an equal sign. So this is part times 100. And then I need the total there. So I'm going to divide by the percentage here. I'm going to divide by the percentage there. So I'm going to end up with a formula that says the total is equal, and you can write this in your cheat sheet as well, times 100 divided by the percentage. Okay, so now I can solve this problem in there. So the part is 13 grams. It's times 100, and it's divided by the percentage, which is 19.99%. And in this case, your answer is going to be in grams, okay? Because the 100 is a percentage and this is a percentage. So those two, they cancel out. And it's going to be 65 grams in there. Your given is 2 sig figs, so your answer has to be in 2 significant figures as well.